Managing a complex world from innovation to commoditization. A quick review of industry literature shows that the average CIO needs to align IT to the business, to keep up with the latest trends, to focus on core activities whilst providing good governance, which means detailed planning. You have to keep IT adaptable and flexible, not forgetting secure, whilst being cost efficient and innovative and providing a good return on investment. You also need to look into software as a service and utility computing, and Web 2.0 and Web 3.0 and Enterprise 2.0. And don't forget business process execution language and modeling notations and TOGAF and open source, and the list goes on and on. It can sometimes even feel like the rest of the business is not always on your side. Infamy, infamy, they've all got it. Infamy. Well, today we're going to explore what's causing this. My name is Simon Wardley. I work and speak in the open source world. So this is a completely new sort of audience for me. So I thought I'd introduce myself with a tag cloud of my passions. And if you look carefully, you may notice that I like ducks. And that's because I have a pond with lots of them. I think ducks are great, unlike turkeys, which I can't stand. Now, I'm a scientist by training, so I always want to understand the processes behind any change. So today, we're going to look at those driving forces behind all the noise, namely commoditization and innovation. We're going to start by defining what commoditization is and how it is impacting our industry. We'll then examine innovation and develop a framework for how stuff happens. I'll then use this to hopefully explain why nothing is simple in management before leaving you with some predictions for the future of enterprise architecture. Before I start, a few words of warning. If there are any designers in the room going, "Is he using Comic Sans?" Well, yes, I am. I know I shouldn't be using it, you'll just have to forgive me. Now, this session shouldn't last more than 40 minutes, and I'm going to try and complete it with 380 slides. I know what you're thinking, but I like to experiment, and in any case, there will be plenty of signposts along the way. So that ends the words of warning, and we'd better start with what commoditization is. Well, the formal definition is change from monopolistic to perfect competition, but I prefer in plain old English, yesterday's hot stuff becomes today's boredom, or alternatively, how something exciting, novel and new grows up to become something that isn't. So what drives commoditization? Well, in the world of business, when someone invents something new, then if it's useful, everyone tries to copy it, until eventually someone releases a product, and then finally, with enough demand, you have a common or utility-like service. There is a constant pressure towards commoditization, as everyone tries to take advantage of a new idea. A good example of this is electricity. Now, back in the 1890s, electricity rocked. It was hot stuff, really, really hot stuff. Electricity mattered. For your average forward-thinking businessman, it provided new competitive opportunities. You could replace expensive labor with shiny new machines powered by electricity. It was an exciting time for the different forms of electricity, from static to dynamic to even therapeutic electricity. Yes, electricity was a powerful constitutional tonic. Of course, in the hands of the amateur, it could have disastrous consequences. Nevertheless, it was exciting and new, and electricity was the stuff the future was made of. By 1904, we had invented the plug, and by 1930s, the national grid. Electricity was common. It had lost its spark. Electricity was yesterday's hot stuff, and that's commoditization for you. It's an ugly word for a beautiful process that creates new opportunity. For example, You need easily available power, data processing and communication before you can have the new stuff like Google. And as Joseph Schumpeter explained, and I won't ask you to read this, the impulse that keeps the capitalist engine in motion is the new stuff, a term known as creative destruction. Now, when something is new or rare in business, we call it a potential source of competitive advantage. When it is common, necessary and ubiquitous, it is described as a cost of doing business. So back in 1996, websites were novel and new. Hence, IT made a strategic difference. IT created competitive advantage, which was great, until Paul Strassman pointed out that IT didn't. Apparently all that was happening was one big arms race, with companies wanting ever bigger and better IT than competitors. And of course every time a company got some new big gun, like an e-commerce site, all its competitors followed suit. And if you weren't armed, you had problems. Much of what we considered to be a source of competitive advantage in 1996 is now ubiquitous and common. It has no strategic value. It is at best a cost of doing business. For example, Web 1.0 has become yesterday's hot stuff. Today it's all about the new stuff, but then that's always been the case. So let's recap. Using the example of the electricity industry, we've talked about the constant pressure towards commoditization as everyone tries to take advantage of a new idea. We've mentioned how this creates new opportunities, a concept known as creative destruction, and how such commoditization is occurring in our industry. Now I'd like to look at how this impacts our industry. To do this, we need to first look at how we build stuff. Whenever we build an application, we repeat a lot of stuff we've done before, like install the infrastructure, common components, a framework, and then afterwards we generally scream at the incompatibility issues. To give an analogy, if house builders built houses like software engineers built software, then for every house they would build a power station, a sewage works and several factories, and they would also scream at the incompatibility issues. Of course, it would be mad to build houses like that, and fortunately they don't. Builders have been doing mashups for centuries, combining commodity-like products and services such as bricks and waterworks to build property. In IT, we are only just starting to learn how to use commodity or common services to build new things. Whether it's with a service-orientated architecture using common internal services, or combining internal and third-party services, or even applications that mash up different services, or applications maintained by third-party providers. We're getting more used to the building with services and dealing with environments where our systems may run on someone else's infrastructure, such as Amazon's EC2. We're starting to learn the art of service architecture, something that builders have been doing since Marcus Vitruvius Polio, author of De Architectura, suggested that you don't build a brand new aqueduct for every villa. Obviously, as the field is new, there are a plethora of different terms, from virtualization to grid computing, from service-orientated architecture to software as a service. My science teacher used to always say before exploring a subject, get simple definitions and images of concepts sorted first. So let's go through each of these terms. Service-orientated architecture, at its simplest, is an architectural style for building web services, building with services. In other words, every house doesn't need its own power station. Virtualization is a technique for abstracting physical hardware. In other words, you get power from a plug You don't need to know what's behind it. Grid computing is a technical architecture for collating computer resources. In other words, it's a national grid rather than a power station. Utility computing is simply a business and provisioning model. In other words, it's a meter. Software as a service is merely a delivery model. In other words, rent rather than buy. Obviously, these services can be combined. For example, a service-oriented architecture may include some software services from third parties, which might be charged for on a utility basis and built on a computing grid that uses virtualization technology. It's all early days. We're still learning. One area which I take particular interest in is software as a service, or SaaS. Now, I normally call this SaaS as in X as a service due to the plethora of different terms such as development as a service, data as a service, platform as a service, hardware as a service, infrastructure as a service, and so on. I'm just going to call them SaaS to begin with. Now, if we examine a software stack from application to framework to hardware, then software as a service is about the further commoditization of a product-based economy to a service one. It's about a transfer of responsibilities from consumer to vendor. Let's look at our software stack. For example, let's take an application provided as a service, such as Salesforce.com's CRM system. Here, a consumer of the service is fundamentally concerned about their data, whilst the provider is concerned with managing the application, framework, and supporting infrastructure. There are hundreds of companies in this field, from Salesforce to Google, with apps from ERP, CRM to Office packages and mail services. Below the application layer in the software stack, you have the development framework. Here you rent a framework and release environment for you to build your own application in. As a user, you need to worry about your data and the application you wrote, whilst the provider is concerned about the framework and supporting infrastructure. Lots of companies in this space, including Bungie Labs, Coghead, and Ning. Below framework on the software stack is hardware. Here we're renting virtual machines, virtual or otherwise. As a user, you need to worry about your data, your apps, and your framework, whilst the provider is concerned about the supporting infrastructure. Numerous companies in this space, including Amazon, Excalibur with Microsoft, IBM, and Google, all expected to join soon. All of these services enable me to focus on building the application whilst cutting out some of the time, money, and effort normally involved in the commonly repeated stuff like capacity planning, installing infrastructure, setting up networks, common libraries, and all the other yak-shaving tasks, as it's commonly called. It's like building a house without worrying where you're going to put the power station. And that sort of stuff makes my life easier. However, it also promises to reduce costs through economies of scale and capex, as you can just pay for what you use. Furthermore, by balancing supply and demand for computer resources somewhat more effectively than today's lunatic situation where everybody builds their own, it should reduce waste, which is good for the planet and hence good for ducks. So software as a service promises to reduce yak shaving, which is good for development, reduce non-strategic cost, which is good for business, and reduce waste, which is good for ducks. It all sounds wonderful, and that's commoditization for you. But what happens when things go wrong with your provider? Now, this may be unlikely. You'd hope that a provider would have better infrastructure than you do. However, something will go wrong at some point. Ideally, when this happens, you just want to switch to another provider. Unfortunately, it's not that simple, as you have a relationship with your provider since your data resides on their infrastructure. This can be solved, and it is possible to have a large number of providers working together in a federated grid, where applications and data can move freely from one to another, whether it's for reasons of price or performance. Unfortunately, this doesn't exist yet, and this will require open standards, open formats, and a core technology to be open source. Until it does exist, you need to carefully consider how to second source and to examine portability, SLAs, and disaster recovery issues. So let's recap. I've talked about commoditization and how yesterday's hot stuff becomes today's boredom. We've covered how there is a constant pressure towards commoditization as everyone tries to take advantage of a new idea. We've looked at how this can create new opportunities, which are the underpinning of our economic system. We've looked at how wasteful the process of building something in IT is, and how new tools and techniques and architectures can help solve this. I've specifically looked at the commoditization of the software stack from product to service and highlighted the potential benefits and potential risks. I now want to turn my attention to what innovation is and to develop a framework for how stuff happens. So far, we've described commoditization as the change from something new to something common. Now, let's ignore most of it and shift it to the side. Whilst we're here, we may as well call a new thing what it is, an innovation. Okay, so we've got from innovation to commodity, but how do we get to innovation? Where do these innovations come from? Well, I have an idea that their origin is in an idea. Okay, but what's an idea? I need some simple definitions. Okay, step in John Locke. According to John, an idea is a term which best serves for whatsoever is the object of understanding. That's good. Let's add that to our fledgling framework. But how do you go from idea to innovation? Step in Jan Fagerberg. According to Jan, innovation is the first attempt to carry out an idea into practice. That's good. Slight problem. Question. Who was the first person to create a wireless radio? Anyone? Why, of course, it was Nikola Tesla. Okay. How about who created the first usable electric light bulb? Yes? Well, the answer is Sir Joseph Wilson Swan. Let's try an easier one. Who flew a kite into a stormy night in order to show that lightning was made of electricity? Got it yet? Why, of course, Thomas Francois Dalibard. How about the first powered controlled sustained air flight? As we all know, it was Felix de Tomple. The problem is, who was first? As Elliot Sivowicz said, whenever you prove who was first, the harder you look, you will find someone else who was more first. So let's modify Jan's law to innovation is the first-ish attempt to carry out an idea into practice. Let's add that to our framework. Now we can go from idea to innovation and on to commoditization. Okay, but where did those ideas come from? Tricky subject. At the beginning of the 14th century, the conventional wisdom was that those ideas came from God. This was challenged by Francesca Petrarch, and the new wisdom was that those ideas came from invention and discovery. Not everyone agrees with this, but let's assume it's right. I'm not expecting anyone here to be from the Spanish Inquisition, but if there is, then please complain to Petrarch. He's dead. So now we have an idea of how innovations turn up. For example, someone discovers global warming. Someone has the idea of using economics to solve the problem, and someone puts this into practice or innovates with tradable carbon permits. We now have a framework for how stuff happens, from invention to commodity. Okay, number of things I wish to note with this framework, other than the fact that I'm taking a lot of liberties. 1. It is not a straight line. As I said earlier, commonly available services allow for new things to be created. So there is feedback. Unfortunately, I'm a rubbish graphics designer, so my attempts to draw this were awful, especially when I added the pictures. As with all rubbish graphics designers, I just took a screenshot, added it to my graphics package, and pressed all the buttons I don't understand. The result was a mess. However, I'm going to use it anyway as a metaphor to explain that the process is not linear but complex with some cyclical aspects. 2. The framework is not just about physical things. I use the example of electricity, but I could equally talk about the spread of a management theory such as Taylor's scientific management or Davenport's process engineering. 3. Not everything spreads. Some things only get so far. Why? Lots of reasons, from physical constraints to not being that useful. 4. Acceleration. There are a number of known accelerators to this process, from network effects, where an innovation becomes more useful the more people adopt it, to the internet, to standards, and even to the open sourcing of technologies. Point 5. Friend and foe. Commoditization can reduce non-strategic costs through economies of scale, which will make any business happy. But there is a sting in the tail. Let's suppose I'm a news provider dispensing news to the masses. Now, cost of doing business activity is distribution. Well, the internet has reduced this until it is so low that my once passive consumers can broadcast news for themselves. The cost of doing business stuff also acted as a barrier to entry, a barrier to participation in this industry. Hence, commoditization can therefore increase competition. So let's recap. We've covered the constant pressure towards commoditization and how this is impacting our industry and the growth of a software as a service market. We've discussed how such commoditization allows for new opportunities, and we've taken a look at where such new stuff comes from and where it doesn't. We've created a framework for how stuff happens. We've noted it's not a straight line. It's not just about things, and not everything spreads. We've also noted that whilst there are accelerators, there are also unintended consequences. Now I want to use this to explore why nothing is simple in management, in order to create some predictions for the future of enterprise architecture. To do this, I'm going to have to create a graphical representation of our framework. As I said, I'm not much of a designer, but I am a scientist, so I like graphs and equations. And I haven't used any today. I know what you're thinking, I know it's late, but I thought I'd give in to a bit of temptation, a bit of what I call science porn. Okay, first we need to know what we're going to graph. What I want to look at is organizational activities, so we're going to need a simple definition for activity. Activity is a process, or sub-process, or result thereof. To make my life easier, I'm also going to use Rogers' S-curve for the diffusion of innovation as a base or primer for my graph. Let's get started. I'll have one axis which I'll call ubiquity, from something novel like a good film with Tom Cruise in to something common like a film with Tom Cruise in. The other axis we will call certainty, from something which we don't know how to solve, like how to build a time machine, to something we do know how to solve, like what is 1 plus 1. Onto these axes I will add an S-curve. Okay, let's now add an activity to our graph. I'll start with something which in the 1980s was relatively unknown and novel: computer-based customer relationship management systems, or CRM. At this time, such systems were so rare and the field so unknown that we didn't even have a name for it. By the mid-80s, a number of companies were building CRM-like systems, often called database marketing. By the early 90s, the first CRM products started to appear. There were even books on the subject. This decade, we've seen utility-like on-demand CRM services. The subject matter is far more ubiquitous and defined. CRM has gone from something which was novel unknown and innovation to something which is commonplace and well-defined, more like a commodity. From innovation to commodity, from hot to not. So let's look at some of the characteristics of something which is hot. Let's pretend to create an innovation. Let's give our innovation a good marketing name. Let's call it Web 3.0. Well, when it's new, there is a scarcity of information about it. There are no good case studies on Web 3.0. It's poorly defined. No one actually knows what Web 3.0 really is. There are few competitors. I'm not sure anyone is using Web 3.0. And it generally costs a lot of money, as in, hello, I'm a Web 3.0 consultant. Now, when it comes to managing such an innovation, then since by very definition it must be different from what already exists, deviation from norms is a good thing. It's new. It can't be the same as the old stuff. So processes designed for change are most suitable. Hence, agile methods are good for innovative pursuits. Furthermore, as a new thing, it has the potential to be a source of competitive advantage. Since no one knows how much it's going to cost, you should focus on worth and value, a VC-like approach to funding. Now let's look at something which is more of a commodity, like a telephone. Well, here there is a wealth of information on telephones. You can probably find a book like My Favorite Telephones in History. Also, how to use one is fairly well known and defined. Most of your competitors have telephones. They are generally low cost, as they are mass-produced in a repeated process. When it comes to managing your telephone system, deviation from normal operation is not a good thing. If I'm installing a telephone system, I want a rigorous and well-defined process. It's not like it's never been done before. And since it's a cost of doing business, I want it as cheap as chips, or as cheap as possible. It's worth remembering, however, that the telephone was once novel and new, and hence expensive, undefined, and so on. The characteristics of any activity changes from innovation to commodity, and hence so does the means of managing it, even though whatever it is remains the same. Things aren't simple. So let's make some general observations. We'll start with methodologies. If you take a snapshot of all the activities within your organization, you will find that most of them are somewhere on that curve, and they are moving. Some are innovations, most are commodity-like. Now, what happens when you decide to create a blanket policy for your organization? Let's say you decide that you're going to use Six Sigma everywhere. Well, it's a good solid methodology, and this will benefit these commodity-like activities by minimizing deviations. However, this will also harm these innovations. The thing to remember is need to use different methodologies for different stages of an activity's life cycle. Okay. Observation 2, outsourcing. Despite a wealth of organizational theory, from classical to systems, we have a tendency to organize by function, with each function containing common activities. IT deals with IT, marketing deals with marketing. However, if you look at a single function, you find it contains a mass of different activities at different stages of their life cycle. Let's now consider the outsourcing of a function such as marketing. Ideally, what we want to outsource is the commodity-like activities, where economies of scale and standards can exist. What we don't want to outsource is the innovative and transitional activities for which there are no economies of scale. To outsource this would be to hand over a future source of profits to a third party. Outsourcing by function can be costly and is inefficient. Okay, observation 3, vendors. Most technology vendors want consumers to perceive their products as innovative, a source of competitive advantage, exclusive and high value. Whilst at the same time, those same vendors want the products to have a wealth of information and case studies, many consumers, and to be low cost to produce and maintain. Generally, vendors want a difference between what something is and how it is perceived by the consumer. This perception gap is generated by activities such as, for example, branding. The final observation I wish to make is about organization itself. Rather than outsourcing by function, I should probably outsource by activity lifecycle. In much the same way that I don't want to apply methodologies across a function, I want to apply them by activity lifecycle. This begs a question. If we need to vary so much by activity lifecycle, why do we organize first by type of activity? Why don't we just organize by activity lifecycle? Why don't we have innovation, transitional and commodity functions? Why do we group by IT, finance and so on? The answer to this is history and habit. We've also lacked the tools to really question how we organize ourselves, from wikis to participation architectures to social networks. This is changing with Enterprise 2.0. However, it should be noted that there is a tendency for organizations to prefer activities in this quarter, well defined, well understood, and with little variation in inputs. Why? Because these activities are, according to Ashby's law, simpler to manage. We appear to have a tendency to try and apply simple, well-defined control mechanisms across all our activities because it makes it easier to manage them. It's a lot harder to manage complex or chaotic systems. Unfortunately, the paradox of innovation is that whilst we need order to survive today, we need disorder to create a future. So let's recap. I have talked about commoditization and how this is happening in our industry with the growth of a software as a service market. We've mentioned how this can be used along with techniques such as service-oriented architecture to create new services or innovations. We've put together a framework for how stuff happens, and whilst we've noted that it is complex, there is also an underlying pattern to this. This pattern explains why nothing is simple in management, why you need to use different methodologies at different stages of an activity's life cycle, why outsourcing by function can have such dubious results, why most things are rarely as they are as they appear, and how our tendency to try and apply simple control processes can also undermine our future. The future is far from simple. This brings me on to my last section and some predictions for enterprise architecture. As we develop architectural skills and become more used to mixing outsourced activities through a growing market of software as service providers into our own service-orientated architectures, then our ability to quickly and cost-effectively release new innovations should increase. We should see a more rapid rate of new service and product innovation. Hence prediction 1, an increase in the rate at which innovative services and products are released to the web. As companies adopt software as a service in order to reduce non-strategic costs, we will see a lowering of the barriers of participation in some industries, resulting in a growth in small startups and competition. Hence prediction 2, more disruption in the information markets. As these software as a service markets develop and we become more adept and successful at managing common activities, whether processes, sub-processes, products or services, there will be an increasing pressure within IT to apply simple control mechanisms across all activities, at the same time as there will be an increasing demand for more innovation. Unless we can solve the innovation paradox, IT will be poured in two polar opposite directions. Hence prediction 3, increasing organizational pressure within IT. Lastly, whilst we use these architectures to increasingly manage our organizational activities, it should be remembered that all activities are in constant flux from innovation to commodity, despite what any vendor might try to convince us of otherwise. Our activities will constantly change in life cycle, and hence our architecture will constantly change as well. Hence prediction 4, the job will never be completed. So that's my 4 predictions. An increase in the rate at which new services are released, more disruption in the information markets, increasing organizational pressure on IT to control and be innovative, and lastly, the enterprise architecture will never be finished. I'm afraid the swirl is just going to get faster and faster, and it's the underlying processes that have got it in for you. Thank you.